In this video, we're going to be talking about linked list. Linked list is a very important collection of data, and it's a very important and common way to implement many of the data structures we're going to study in the future. So basically, a linked list is a collection of linked nodes. We're going to be linking nodes using references in Java, which are nothing else but addresses. And then every node contains basically two fields, two pieces of information. One field is called data, and data is a generic name for the type of the object we want to store in our collection. So we're going to see that data is going to be perhaps of a string class type, or it's going to be a random number class type, or any other class that we have created in Java. So basically, data is an object, and our linked list will have many of those objects. The other field is called next, and next is simply a reference, which again is an address in Java, and is an address of the next node in the linked list. So typically, a linked list looks like this. So those circles are the nodes, and every node has two pieces of information. One is the data, which in this case is single letter, like in G or O or in T. And again, that could be any type that we want to define later on in our class. And then the second field is next, and next is this little arrow that we're going to use to say this node that contains the value G has a field called next that refers or links the node that contains the G with the nodes that contains the T. And then the node that contains the T has also a field called next, but that links or connects the node that has the T with the node that has the O. And finally, the last node has data, which in this case is O, but the field next is not referring to another object. It simply has a special value for a reference in Java that is called null. So null will indicate that a reference is not being used. But more importantly, in a linked list, a reference that has value node indicates that the object that has that reference is the last object in the collection, is the last object on the linked list. Notice that we have another reference here that is called front. So typically, a linked list has a reference that will indicate where the first node on the list is. This is what we call an external reference. External because this reference is not attached to any node. This reference simply is used to know the address of the first node where the list starts. I have created a class called myNode. So in order to implement the linked list of nodes, I'm going to first create or implement a class for a single node. And then this class called myNode, you're going to see in other videos, is being used to represent anything that allows us to represent using what is called reference-based implementations. So the myNode class will be used to implement linked lists, to implement binary trees, to implement stacks, queues, and many other data structures. What you see then is the implementation of this class, which is called myNode. And again, this is not the implementation of a linked list, this is the implementation of a single node in the linked list that I'm creating later on. And as explained, there are two pieces or two fields, two pieces of information or two fields, which are both private, so I can have some level of protection, and one is called data. And as usual, that's just a generic placeholder for any object of any class. And then I have my other field, which is called next, and next is of type myNode itself. So this is a little bit different than any definition that perhaps you had seen before, because it's using the word myNode to define itself. So this is like a circular reference to itself. Bottom line is that the node has just two pieces of information. One is the field called data. That's the one that contains the object. And the field that is called next, this is the one that we're going to use to link one node to the other. As any other class, we have a constructor, and the constructor requires two parameters. What is the value of the object that we're going to store in that node, and what is the value of the reference for that node? And remember, this is a reference. So in Java, there are only two possible values for this reference. One is going to be an address of the node that follows this one, so we're linking or connecting one node to the other, or it's going to be null, indicating that that reference is not being used. As you remember in the picture I just showed you, the very last node on the linked list, this field called next will have value null to indicate that that is the last node. Anyhow, whatever those two values are, we're going to use these two other methods, which I'm about to explain, to store the values of data and next in the proper fields. So what is set data? Set data is what we call a mutator. It's something that produces a change. In this case, it's going to change the value of the field. Obviously, the value of the field that we call data takes a parameter, which is an object. Okay, remember E is a placeholder for any object, and then initialize data to that parameter. Get data is the corresponding accessor for the field data. This allows us to retrieve the value of the data. So it's going to return an object. So it's a very simple method. All it does is to return the data. And then to finish this class, which is a very small class, I need the accessor, a mutator, for the next field. So I have a setNext method, which allows me to change the value of the reference that we call next. And again, it requires a parameter with the value of that reference. One more time, this could be an address, so that next will link to another node, or it could be null. Either way, this statement assigns the value to the field next. And finally, I have a method that allows me to retrieve the value of my reference called next, and I simply need to say return next, and remember, this is going to return two possible things: an address that refers to an object, hopefully the object that follows the one that we are talking about, or it's going to be null, indicating that there is no node after that. So again, typically the picture of the linked list looks like the one that you're seeing before in front of you. It's a collection of nodes which are linked, which are connected, where each node connects to the next one. This is very important because we're going to see other type of linked lists where we have a reference that connects the node to the previous node. Next is what is indicating. It's a reference to the node that follows in the list. That reference is going to have either the value of the object that follows the next node on the list, or it's going to have the value null, which indicates there is nothing after, and that typically is used to signal the end of the node. And as you can see on the picture, there is something that we call front, and that tells you where the list starts. You're going to see different notations for this. It's sometimes called head, front, it's called first. Bottom line is you need a reference that will tell you where you can find the node that starts the list. What is the address of the first node on the list? You also are very likely to find many diagrams when you go into the internet representing different things. So here I'm just showing you two diagrams, okay? One here uses boxes, but essentially every box represents a node, and notice that the node has two fields, one called data. In this case, data is numerical values like 20, 10, 50, and 40, and then has a field called next, which is a reference that links to the next node. And also notice that the last node, the value of next, is null. This diagram is not showing you the address of the first node. The second diagram, again, is the same thing. It's using boxes, and it's clear that each node has two fields, right? You don't see the name data and the name next, but it's clear that the reference is connecting to the next node. And then the next in the last node indicates I'm not connected to anything. There is no node after me, so the reference is set null. And here we have something that looks slightly different. Okay, this doesn't have two fields indicating this is not a node. This is just simply a reference like any one of these ones down below. So there are different ways of drawing diagrams for a linked list, but all are trying to convey the same representation. It's a collection of nodes where each node has a reference to the node that follows. The last node reference is set to null, and there is an external reference that will tell us the address of the first node in the list.